Troubleshooting for this pump. Yes, sometimes people are worried about what is the troubles they can have on the real installation. So I'm here to try to explain some of the most common mistakes that are made in the installation side. You already know, if you listen to the previous videos, I can tell you 90% of the faults for Evoplus and for circulators in general comes from the wrong installation. This is a wrong installation. You know why? Vertical shaft, the water passing through the impeller doesn't cool enough the motor on top. The pump is not gonna last for long in this condition. 1 month, 2 months, not much longer. So every time we get a fault on this type of pumps, I can tell you 90% is because the installer didn't know this rule and installed the pump like that or like that. This is also wrong because in this case the water with the dirty, with the debris, with some solid particles go inside the pump, doesn't go out anymore, and it can create some friction into the motor. So also this configuration is very wrong. Remember, shaft must be horizontal to the ground. If we do this right, we solve 90% of our cases. Another mistake can come from the place of installation because this pump is not designed to stay in the elements, in the outdoor conditions. So remember to put this pump covered, installed in an indoor room, in a technical vein. If you put on the roof out on the elements, don't forget to put a proper cover around it. Another problem that sometimes people make is getting rid of these insulating shields and putting around the pump their own insulation. Great, you can do that on the pipeline, on top and on the bottom. It's always great to insulate the pipeline, but please, around the pump, keep the original parts, because these shields have a hole on the side that allow the pump to evacuate the condensation that comes from hot and cold touching together. So there is always some sort of condensation inside this pump that must be getting rid by these little holes that we can find in here. Through this hole, the pump is actually breathing, and the shield, the original shield, they allow this hole to remain clear. Okay, while if you put your own cover, you actually choke that hole, the pump doesn't breathe anymore, and this is a way to destroy the pump from inside with rust and with corrosion. Other problems can be a wrong electrical connection. If you, for example, connect the connector in the wrong way, or you damage the pins here, so when the pump doesn't turn on, remember always to check the electrical connection. Probably the last type of problem that you might find in installation is when your pump doesn't meet the performance that you expect. That can be due mainly to 2 reasons. Your set point is not set at the right value, you forgot to increase it at the good point, or if you can't reach the right flow, it's probably because you set the set point too high, and when the set point in pressure is too high, the pump cannot provide enough flow for that pressure. Or there can be the third reason that unfortunately doesn't depend on the pump, but is that you choose the wrong pump for that duty. Sometimes choosing the pump is more critical than installing the pump, because you have to make sure that the duty point has been calculated properly, and you have to choose the pump that covers. Sometimes pump can be undersized. So these are the typical problems that you can find. What about if you choose an oversized pump? is also a problem because you're actually wasting a little bit of energy because the pump is bigger than what it should be. But that problem is now solved when you choose a variable frequency driver pump. If the pump is oversized, but it has a VFD on it, the variable frequency driver is able to modulate, getting the pump working slower, lower power consumption, doing the performance that you just require. There is no waste, and the problem is actually solved. So no more oversizing, but be careful to the undersizing.